Okay, so we're going to look at examples again of piecewise functions, and we started these last week. And so let's say you're given a function, how about g of x is equal to, there's three separate equations in this piecewise function. We have the equation, the square root, underneath that radical, 10 minus x squared. And this is for values where x is smaller than -1. We have the second equation is 26 minus 5x squared all over 7. This actually is between -1 is less than x is less than or equal to -1. I'm sorry, not -1, e. And then the third equation is the natural log of x cubed. And this is for x is greater than e. So it asks us, find the limit as x is approaching -1 of the function g of x. So if we were looking at a limit and that x value was not approaching one of the n values of our inequality, we would be okay. But we're looking at a limit where we're approaching one side, or we're approaching the bound of our inequality. And so our left and our right-hand side limit could be different. And so we need to look at the left-hand side limit and we need to look at the right-hand side limit. So let's first look at the left-hand side. So let's first look at the limit as x is approaching this -1. On the left-hand side, we put that negative superscript. So those are for values which are smaller than -1. And so if you look at your equation, goodness, then we're going to plug in smaller numbers less than -1, and we're going to use this first equation. So this first equation is the square root of 10 minus x squared. So let's just do our direct substitution. So we have the square root 10 minus, put parentheses there. We're going to square that parentheses and we're plugging in -1. And then simplify. So this is the square root of 10 minus 1, or the square root of 9, which is equal to 3. Okay, so the left-hand limit gave us back 3. So now we want to look at the right-hand side limit. So let's look at the limit as x is approaching -1 from the right-hand side. So we're going to put this plus, and this looks like a exponent. These are values where x are greater than 1 here, or -1. So values where x are greater than -1, but closest to the right, which equation we would use would be this one, the second one. So here we're going to write 26 minus 5x squared all over 7. Do direct substitution, and now wherever you see an x, we're going to plug in that -1. So you have 26 minus 5, I see an x, so parentheses squared all over 7. Plug in -1 into the parentheses, and then order of operations, simplify the numerator. So you have 26 minus, well, -1 squared is 1, so 1 times is 5, so -5 all over 7. So 26 minus 5 is 21 all over 7, which is 3. So notice that our left-hand limit was 3 and our right-hand limit is 3. And so we can say that the limit as x approaches -1 of g of x exists, and it is 3. And that was because the left and right hand limits, again, are the same. What if the next question said, though, what is the limit as x approaches e? So x approaches e, that's another bound on that inequality. So I'm just going to go to the next page and I'm going to rewrite that down. And we're going to look at the limit as x approaches e. Just rewriting g of x really quick. We had the square root of 10 minus x squared. That was if x was less than -1. We had the fraction 26 minus 5x squared over 7. This was if x was between -1 and e. And the last one, we had the natural log of x cubed, and this was x was greater than e. And we want to, this was part B, let's say, find the limit as x approaches e. So that, again, is one of our bounds. So we want to look at the left and the right hand limit. And so let's look at the left hand limit. So this would be the limit as x is approaching e from the left hand side. And so that's telling me that I'm looking at values of x. So use the equation where x is less than e, but you're using the equation where it's the closest to. So we'd have to look at the second equation. So let's go back in there and plug in e wherever we see an x. And 26 minus 5x squared over 7. So 26 minus 5 all times e quantity squared all over 7. Technically, I would need a calculator or I would have to leave it like that. So 26 minus 5 times e on your calculator is probably above their natural log button. I'm going to square it. E is just a number, just like pi is a number. And we're going to divide that by 7. And I'm going to approximate. So I'm going to make that squiggly equal sign, meaning that I approximated here. I rounded my answer. So if we do that, you should get about -1.56. Okay, so now I want to look at the limit as x approaches e on the right-hand side. And so those are values where our value of x is greater than e. So greater than e, we want to use that third equation, the natural log of x cubed. So that's an L, not a 1N. Do direct substitution. So I have a natural log parentheses, and then that parentheses cubed. Okay, so kind of recall, first of all, what is a log? So we have the natural log of is log base e. So this is just another way to say log base e of e cubed. So recall logs, it's basically an exponent. So we're thinking to ourselves, what exponent would we use to raise our base to? What would we raise e to get back this e cubed? So this is saying e to what value equals e cubed? Well, I know if I cube e, I would get back e cubed. So that value, that exponent, has to be a 3. And so this is equal to 3. So one limit coming on the left, I get about negative 1.56. Coming in on the right, I'm approaching 3. These are not the same values. And so the limit doesn't exist. So limit as x approaches e of g of x does not exist, d and e. Okay, so if we graph that, there would be some jump in the graph there at x equals e. Any questions on that?